All right, let's get started then. So, hey everyone, my name is Tom McQuillan. I work at GDevCon. You might know me from perhaps Tom's LabVIEW Adventure on YouTube. Thanks. Or I have an online training course, Udemy/Learn LabVIEW. And yeah, reach out to me on LinkedIn and stuff. This is my first time at GDevCon N.A. Thank you very much for having me. It's great to see people like Derek from Discord and Jeff from the forums and putting names to faces. And yeah, it's great to see you all. Loads of you have come up to me and said hello, which is great. Please keep doing that. So yeah, thank you for indulging my presentation. This presentation has nothing to do about work. It's just a hobby project I did over a weekend, and I thought you might find it a bit fun. So my current fixation is learning the piano. And thanks to Andy's presentation earlier, I'm excited to be twice as likely to get a Nobel Prize for that. So I'll keep you all in my acceptance speech for that prize. And I'm not very good at piano, so don't expect a proper demonstration. But as I've been learning to play, I keep seeing this box on my piano, and I'm like, oh, the things I could do with this I/O board. Like as a LabVIEW developer, I'm like, what can I do in LabVIEW to talk to my piano? Like, okay, I'll learn MIDI. MIDI is just a serial driver, right? MIDI being musical instrument digital interface, or similar. It's a serial driver. I can connect to LabVIEW. LabVIEW can connect to anything. Awesome. But before communicating to the piano, I need some sort of user interface. And I'm my own customer, so I just made it up as I went along. Okay, demo number 1. And I'm doing this demo on a virtual machine on a laptop that's not plugged in. So let's see how this goes. Okay. You know, a better presenter would have checked this before. Okay, no, I think it is connected. Nice. So the first thing I needed was a user interface. So I'm going to do a live demonstration. Hopefully it works. Hopefully it loads. Awesome. There's now a piano on my screen. Oh, and it does work. Great. And so my basic user interface, I can move my cursor over the piano keys. Also, huh? Thank you. That's Beethoven's Felice, if anyone's interested. Also, everything in LabVIEW is scalable. Of course, we can maximize this, make the user interface, change it. I sort of had this idea that I wanted a MIDI player that could load all of the notes and stream it into the keyboard, which meant I needed to have this user interface be like pinned to different sides, maybe to the bottom for like a falling rain. Maybe I put it to the right. Cool. All right. First demonstration, complete, successful, amazing. I don't need that pre-recorded video. Okay, so the way that I created that user interface was to use a 2D picture control. And with 2D picture controls, you just need to be able to describe a thing using math, or maths if you do it more than once. So this piano, this was extremely cheap off Amazon just for this presentation, so I'm not too hopeful for it. But I can describe this using math because it has 55 white keys, or if it was a proper sized piano, 55 white keys on this side, but on this side it has 88 keys. So I can divide my 2D picture control by 88 for the white and black keys, or 55 for the white keys. I know that a black key is 2/3 of the length of a white key. I know there's a ratio between the width of a white key, which I know is the width of my 2D control over 55, and the height of the white key. is apparently 150 over what, 22, 23. And so with that, I can draw my keyboard. This is the first time I've ever used a maths box function. What's it called? Formula node. And basically, from my dimensions, I could point out the corners of the polygon, which is my key. So I'm looking at, where's my laptop? Oh, it's over here. So I'm looking at like each of the corners of this key. That's a polygon. Polygons are maths and awesome. And then I multiply that for 8 octaves, or however many. Once I have a mathematical model of what a piano is, I can, in LabVIEW, use these functions to create that image. And I'm creating 2 images, one for when the note is being pressed and one for, well, when it's not. I put that into a map so I can reference it later. When I want to publish that keyboard to the UI, I have an array of images. I concatenate them together. Think of a picture as a string. You can concatenate them and then show on the user interface. Cool. Oh yeah, so how does LabVIEW know where on my user interface I have my cursor? Well, in LabVIEW, I'm just tracking mouth movements, events. And then for every piano key, I'm just looking, is my cursor inside that polygon? And if it is, I stop this loop and it's valid. Now, I was skeptical. I thought every time I move my cursor, I'm doing 88 polygon checks. Like, that feels like a lot, right? The thing is, this is all maths, and maths is really quick. LabVIEW as a language is really quick, and we should give it more credit than I think we do. So like one idea I had was split my 2D pitch control into individual octaves, but I'm only checking 12 keys at a time. I can do parallel processing, check. But I didn't need to. For a user interface, this was plenty fast enough. To the user, me, to the main customer, me, it seemed to update straight away without delays. It's just general settings for the 2D picture box. I always erase the image first, or otherwise all of your on notes will remain on. Enable smooth updates. And just scale the box with your pane. These settings I just found out about on the N.A forums. I think it was Darren. Where's Darren? I thought he was over there. Yeah, there he is. Darren has a few forum posts on which settings to select and why. Okay, user interface complete. I only have 20 minutes or so for this presentation. So straight on to MIDI out. Now, I studied the MIDI specification. It's like, oh, great, it's a serial device. I'm going to, I don't know, just use Visa, perhaps. If I want to turn on a note, I send the command 93C40. That will turn on middle C, that note, at a middle volume. The velocity is how quickly I press the key. I can play a key softly or play it hard. Okay, so I can use Visa, right? Connect to the keyboard, send a command. Did everyone know about the hex format string, where you can do like code display or password display? Anyway, so yeah, that doesn't work because MIDI and Visa are just, they're not compatible. And so as soon as I saw, my MIDI device isn't showing up in this drop-down menu, but maybe it shows up in other drop-down menus. So I went to Macs, and I was like, it's going to show up there, right? No. I looked at Windows Device Monitor, and so it does show up under sound, video games, and game controllers. So I thought, oh, maybe the ExpressVI might pick it up. And if it does pick it up, then I can open the front panel of that ExpressVI, look at the code, copy and paste it, steal it, use it. But no, that didn't work either. So what did I do? I Googled it and found the Windows driver that connects to MIDI. And at this point, I was like, oh, I don't want to use someone else's code. And then a friend convinced me that if it was written in Visa, you're using someone else's code anyway. Visa makes it super easy. So I was like, okay, fine. I'll use this DLL. And I could read the documentation, but I wasn't going to. I asked Claude, hey, using this DLL, what are the parameters I need? What are the functions just to turn a note on and off? And it says, oh, I need these 3 functions. And it even told me, how to format that data. So in like 10 minutes, you'll be able to use a core library function node, connect to the library, these functions. And yeah, it's useful when you're told the data types as well. So yeah, that worked, that was straightforward. What's on the next slide? And so before too long, I had a working proof of concept that could just do a chromatic scale from the lowest note on your MIDI keyboard to the highest note. So starting with note 0 on your bass end, all the way to note 127, which is way up here. It doesn't exist on a standard piano. Cool, so we've now masters of MIDI out. We can just use the Windows DLL, call it in LabVIEW. It worked fine, there's no complex processing at all. But I sort of wanted to be able to, play notes on my piano and be able to see that in LabVIEW. And I figured, okay, I need to use a DLL. I can't use Visa. How do I do that? And how do I make it event-driven? Because, I could poll a function every 10 milliseconds and just see if, like, a key has been pressed. But that's a bit rubbish. I don't want a polling application. So how do I pass a user event reference into this DLL and then get the DLL to send a LabVIEW user event to trigger this event structure? Oh, I'm glad you asked. So what I have to do, this Windows Media Player DLL will generate a callback, or rather, it registers with window to generate an event. Every time a key is pressed, then how do I go from this callback into a LabVIEW user event? Well, I'm going to have to do some sort of wrapping. Not like that, just wrapping the DLL into tommidilun.dll. And I decided to wrap all of the functions I needed anyway. So I just had one cohesive DLL I was calling. And for the most part, like MIDI in, start, stop, close, I did a direct wrapper. I didn't really write any code. I have my LabVIEW function, which I will call, and that just returns the Windows function. So like, there's no complex code in there. Oh yeah, so that's MIDI start, stop, close. But MIDI open, this is where I need to register that user event. So I'm still going to call MIDI in open, that's the Windows function. LabVIEW MIDI in open, that's the LabVIEW function I've created. I'm going to pass in a user event reference using the LabVIEW user event ref data type. Actually, once I got this working, I realized it was sending events every like 50 milliseconds or something as a heartbeat. So I very quickly implemented some filtering. So I passed in a filter, so I only want note on or note off events. In then, I need to specify some sort of callback function. That callback function, again, is actually quite straightforward. The first thing I do is, if this reference is valid, move on to the next step. So if it's valid, I'm going to look at the data, parse the data into the status, data 1, data 2, that I can use later on in the code. And if that all works okay, I check, is that user event one of the ones I wanted? Is it a note on or note off? And if so, I use the post LabVIEW user event function. This is in your standard C library. So the LabVIEW C library, there's documentation online on all these fun functions. So I call this function and, oh yeah, and it sends LabVIEW a user event. The way of passing that user event reference into the call library function node, I typically just use adapter type. Then I can pass the reference directly in. Other people typecast to a U64 or U32. I find adapter type, I'm less likely to make a mistake. Even once I receive that user event, what am I doing? Oh yeah, once I receive that user event, remember all of that 2D picture control stuff I did earlier? Well, all of those images ended up in an array. And I can use some map lookups to see, okay, which polygon now needs to turn on, which needs to turn off. And I can index by name, switch the array element. So the keyboard is in an array, and I switch, and I change array element. Even at the bottom here, I figured I'm likely to want to turn on and off multiple keys at the same time. So I'm going to do all of the maths, all of the processing up front, and then just send the result to the user interface using this function. 10 points if you can tell me what the name of this function is. Yep. Set value by index, perfect, 10 points. And if you're unfamiliar with a presentation technique, if you forget the answer yourself, make it a quiz. Cool. Now, I wanted to do a quick demonstration, but I forgot. So let's just demo MIDI in to see that working. If I do C major, wonderful. Reading MIDI files. Okay, I have 5 minutes, awesome. Reading MIDI files. I wanted to write this in a language that was cross-platform and high performing. So which language do you think I used to write a MIDI file driver? English? Yeah. So I've realized I've been neglecting this side of the room. I'm gonna come over here. Okay, this side of the room, which language should I have used? A few people are saying Python. Like, no! So it's really slow. LabVIEW, yes, LabVIEW is high performant and cross-platform. So I wrote it in LabVIEW. I read the file specification, and much like a device driver, a file specification tells you what all the bytes mean in a file. So the header data in this specification, I want a literal string of 4 bytes and MTHD, I know, MIDI something. It just tells us this is a MIDI file. And then there's some header data to tell us the format of that MIDI data. And at this stage, I wanted to experiment with a few different ways of reading that file to compare speed and memory management. So with reading binary files, you can choose to read as much or as little data as you want. So my first thought was, oh, okay, I'll just do this. I want 4 bytes, so I thought I'll initialize a byte array with 4 elements. That didn't work. So I moved on to approach 1, where I read 4 bytes as a string, and for my empty HD, I can then read a bunch of other numbers. And then at the end, I can read the rest of the array. I could read from the file individual data bits, but this worked, and I guess memory, optimized for memory users, but I mean, it's really slow. And I didn't quite appreciate how slow file I/O operations work. So I ended up just reading the whole file in then as a byte array. And then I can split the array into, okay, I want 4 bytes for the string, 4 bytes for a U32 value. The specification is there. And that's super fast. And you're not going to get a MIDI file that's a couple gig, so it's fine. And that's what I ended up doing in my final API. With the first 2 methods, I just read the first 4 bytes of a file to see, is it MTHD? And then if it is, I read the header data, and that can give me some more information. And then I just read the rest of the file if I don't have any errors. Okay, and then getting the file tracks. So a MIDI file could have multiple tracks, and they could be set up to play concurrently or sequentially. For piano players, you tend to have like 2 tracks, one for the left hand, one for the right hand, which you play at the same time. And so this piece of code will split the remaining data into the individual tracks. Then I can process that data in parallel. The data which I am then processing in parallel are things like the message type. Am I turning a note on or off? Am I pressing the sustain pedal? Or is there some custom data in the MIDI file? Now, annoyingly, even though these 3 data packets are all the same data size, the MIDI file can contain data of any size. So you can't just read 32 bytes and do everything in parallel. You have to read sequentially. So I ended up with some code that looks like this, keeping everything in a shift register. Ooh. Keeping everything in a shift register, then like I did before, using the split array function somewhere here. Yeah. And depending on what I'm trying to interpret, I can get the data and pass it out as an array of objects. A note I've put on the screen there is a numeric map is a lot faster than a string map. After I initially used a string as a GUID, but I found it took so long to do lookups, because ultimately I could have thousands and thousands of file events. And if I do an array lookup using strings, like there's no real sorting there. It's super slow. So I just typecast it to a U64. I lost half of the data of the GUID, but I only need a few thousand UIDs. I don't need, what, quintillions, 18 quintillion possible note values. Cool. And then, wouldn't it be nice if I could use all of that data I've read from the file and play it? It would be, wouldn't it? Right. Because that's what I'm going to subject you to now. OK. Demo MIDI player. Again, I'm going to re-emphasize I'm running this on a heavily abused virtual machine. I have a similar UI from before. Good, my piano is still connected. Let's connect to that. And I'm going to open a file. The Chopin Waltz in A minor is a classic that every beginner piano player learns. And hopefully, yeah, okay, that plays. And that's just using the techniques I've used in this presentation. Now, that's fine. It's a bit dull. It's a bit of an elementary piano piece to learn. One piece which is way outside of my ability is Chopin's Fantasia Impromptu. Now, that actually loaded really quickly. I was about to say, a better programmer would have pipelined it onto the user interface. You don't need that. All right, again, virtual machine. Okay, we'll see how well this works. Okay, not too bad. Nice. And obviously I've got play, pause, stop, resume. I think the ultimate, you all know like Beethoven's Fifth Symphony. Da-da-da-dun. Yeah. All right. This MIDI file does occasionally crash it, but I was told I could go a bit over, so we can try it out. Now this does take a long time because there are a few, I think 4,000 individual notes which need to be sequentially rendered and read. We'll see how well the timing syncs up here. Oh. Okay. And I think the important thing to note here is all of these notes are being played on demand. I am sending a request to the piano at the time the note needs to be played and when it needs to be stopped. So actually, I'm quite pleased this is working all right. What's that? Okay, well, that's the end of the presentation. Thank you very much.